Hi, good morning, year 6. We're going to do another science video lesson now, okay? Now we're going to continue on in our lessons on friction. Today we're going to look at something called water resistance, all right? So I'm calling this lesson Friction 3, Water Resistance. Now before we begin, let's do a review of our other two lessons, okay? So we looked at friction is when two surfaces are rubbing against each other, slowing down that moving object. All right? So we're pushing an object. It's going forward, but friction is pushing in the other direction. All right? That's friction. All right. Earlier in this week, we looked at air resistance. It's a type of friction, but it's for objects moving through air. So an object moving through the air being slowed down by particles in the air pushing against the front of that object. So here I have a car, all right? So the car has a medium level air resistance on the front, okay? That front is pretty flat, and you can see with the arrow, it's showing where the wind is hitting. So the air is hitting at the front, that flat surface. We have a lorry on the right side, and it has a bigger flat surface facing the air moving by, and it creates more air resistance. All right. Here we have a picture of a sports car. Its shape means there will be lower air resistance. There's still air resistance, it's just lower. Okay. So we looked at the smaller the surface, the smaller the air resistance. The larger the surface, the larger the air resistance. Okay? And this shape that allows air to move over it or it doesn't catch air, we can call that streamlined. Okay, so this sports car is streamlined. It lets the air pass through it without catching it. All right, increasing and decreasing air resistance. We have the same piece of paper, okay? One has a large surface area, one has a small surface area. Which one will fall quicker? Okay, the large surface area on the left will fall slower, and the scrunched up ball of paper will fall quicker. Parachutes, okay? So this is where we're using air resistance to help us. Which one will catch more air? Okay, the larger air surface, okay? So it'll catch more air, there's more air resistance. The gravity is the same, so the larger parachute will fall slower. Okay, and it's not just the size, okay? It's also the shape. So you can change the shape that will affect the size of what the air is contacting. So the same biker sitting up is catching a lot of air, but if you take a position like that allows the air to pass through you don't have a flat surface, okay, you'll catch less air and you need less force to go as fast, or you can go faster. All right, now we're going to stretch that to a third type of friction today. We'll apply those same things we're just looking at. We're going to look at water resistance, okay? Now water resistance is very similar to air resistance, just it takes place in water. All right. Have you ever tried running in water? Maybe at the beach you're running in to see who can get to the sand the quickest, or maybe in the pool you're running like this to get the ball while you're playing water polo. You notice it's very, very hard, especially when you're standing upright. If you dive with your hands in front of you in a aerodynamic shape, a streamlined shape, you can go quicker. All right? Now, here we have someone running through the air. Which one is more difficult? Can you go faster running in the pool or faster running in the air? Okay? So I think you know that it takes more force running through water. There's more resistance. So water resistance works the same as air resistance, just there's more of it. Okay, that's why I use the larger arrow to show there's more resistance. Okay, now water resistance we have an animal here, a penguin, that has a very good shape to pass through the water. If you look at penguins walking on the land, they look very awkward. In the water, they can pass through very easily. They can swim very quick, okay? So water resistance is a force that tries to slow things down that are moving through water. It is a type of friction. It's sometimes called drag. So similar to air resistance, we can use that word drag, all right? And the shape that lets the water to pass over the penguin easier, okay, this is also called streamlined, the same as air resistance. Okay, so streamlined, the definition is it's a design with a form that presents very little resistance to a flow of air or water, it increasing the speed and ease of movement. All right, so I put 3 boats here. We have a pointy front rowboat, a flat front rowboat, and a pointy and narrow kayak, A, B, and C. Right. Let's say we were using the same force, okay? Which one is going to go quicker? Okay? Or we could think, if we're going the same speed, which one would take less force to go a certain speed? Which one would be easier to paddle? Now, when we're looking at water resistance, we can think which one would catch the least water or the most water. Okay, let's start with first, let's think of what would be the easiest to paddle. Yes, C would be the easiest to paddle because it's more streamlined. And which one would be second easiest? A, that's right. It has a point, but it's still a little bit wider. It still has more surface catching the water. And B, it would catch a lot of water, so it wouldn't paddle with very much ease. Now, it doesn't mean that B is a bad boat. This is a type of boat you would use if you're not paddling far, if you want to stay in the water and be balanced, okay? C moves quickly, but it's very easy to tip over, actually. Maybe people using B would use a gasoline engine as well, so they wouldn't be paddling it. All right, so sometimes we want low resistance, like here. It's going to be easier to paddle the one on the right, okay? But sometimes we want high water resistance as well. So if you look at this girl paddling here, she has the handle of the paddle is very thin, but the blade, the part that goes through the water, has a large surface area, so it's catching a lot of the water. All right, this guy has a very narrow paddle, so you're not going to be able to move your boat as quickly with that one. All right, so more water resistance can be a good thing. All right, I don't want you just to think that drag is a bad thing. All right, that's it for our lesson today. In conclusion, we've learned 3 types of friction this week. Okay, there is just the standard friction with 2 surfaces rubbing, slowing down a moving object. Okay, that's one object moving across another one. We had air resistance. That's particles in the air slowing down objects moving through the air. So parachutes, baseball being hit, cars driving down the road. And today we looked at water resistance. So water slowing down objects moving through water. Just think of you trying to run through the school pool. It takes a lot of effort. You're exhausted after that, right? Okay. A term we looked at today, drag. That's just another name for air and water resistance. Drag is a force that's always opposite to the object's motion. So if you're running this way, the drag is pushing the other way. Streamline. It's a design that presents very little resistance to the flow of air or water, increasing speed and ease of movement. Okay, so a sports car is a nice streamlined design. A penguin is very streamlined for water. Okay, sometimes we want high friction. Okay, sometimes we want high air and water resistance. Sometimes we want low air and water resistance. Okay, just like in a boat, it's going to be a lot of hard work to paddle a flat boat, okay? So we want low water resistance there. But if we have a paddle, if we want to push a lot of water, we would want a paddle that has large water resistance. Great. All right, so today's Friday. For the weekend, I'd like you to prepare a few items to have ready for Monday's class. Monday, we're going to do a little friction investigation, okay? So what you need is a toy car. It can be any kind of car. You should have one around your house. I prefer you not go out and buy one, but all it has to be able to do is it can roll. If it's on a hill, it will roll down. It doesn't have to be one you pull back and let go. It can be, okay? The other thing you need is a ramp, okay? I just use a piece of cardboard. It only has to be 50 centimeters long. If it is 40 centimeters long, that's fine. And you need to have something that can hold that ramp up 10 centimeters tall. I used a tissue box. I cut it in half, and it's up 10 centimeters. If you want to stack some books up, or if you have one big dictionary, you could do that. And ideally, you would have a measuring tape, okay? I have one I got from shopping at IKEA. You should have one around your house. If you don't, we will have to find a standard of measuring things. We can look at that on Monday, all right? What we're going to look at is friction on a surface and how far our toy cars will roll. We'll put our car up on the ramp like this and roll it down. So here's my... I've got my equipment at home. I made a ramp out of some cardboard. It's 50 centimeters long and 10 centimeters high. I have my toy minibus ready. It can roll down the hill, and I have my measuring tape ready as well. Okay, so here's a nice video of me just showing you in slow motion rolling down my ramp. Okay, there it goes, a little tap. All right, great. So have that equipment ready on Monday, and we'll do some investigations. Right now, I have a definition matching assignment set up on Quizlet. So below here in the activity, you'll see a link to Quizlet, and there will be the important words from our unit so far, okay? I think the vocabulary, you might have an understanding of it, but it's good if we can be sure we know the vocabulary. So follow that. There's a few different things you can do. You can do a matching game. Just in the comments here, you can write how many seconds it took you to match all the cards. Okay, so it could be 30 seconds, it could be 2 minutes. It's a good little way to get used to our vocabulary. All right, year 6, have a great weekend. I'll see you back here on Monday, and have your measuring tape, your ramp, and your toy car ready. All right, guys. See you later.